So the last topic to discuss in this set about pieces of bacon and the greedy fellow there is to define a typical value for how much bacon is taken by a typical person on a typical day at this typical breakfast buffet. So that idea there is sort of important. Typical value. So it should stand to reason. If you were doing a median style analysis, then the three numbers you care about are here. So when you are talking about a typical value, then this particular value, the median, is that number in the center. And then your Q1 and Q3 bound the range where most data points fall. And if you think about that, the quartiles, each bin has four, like a quarter of the data points, plus one in the center for the median. So if you go between Q1 and Q3, you're getting at least half the data points. And I say at least like as though you might get 75%. That's not true. But you're getting like half the data sitting in that particular box. So that's a good window for defining a typical value. So under the median type analysis, you would say that a typical value, according to the median, median of 4, and most data points are between 3 and 4.5. So your typical value of how much bacon someone takes at this particular buffet is between 3 and 4.5 slices of bacon. Please stop them if you see them taking that half piece and then putting half back, because that's gross. But mathematically, that's what they're doing. Under the mean and standard deviation version, so you'd have a mean value of 3.95. And in order to decide the typical value there, we're going to go from this mean value up a standard deviation and down a standard deviation in order to construct a window like Q1 and Q3 that will bound how many data points, or to find a boundary where most of the data points will sit. So if I take my mean of 3.95 and I subtract one standard deviation, I get 1.284, 2.666, and if I were to add one, 3.95, my mean value, plus one standard deviation, so plus 1.284, gives me 5.234. So according to the mean value and standard deviation definition, the typical value falls between these values here. So a typical person on a typical day takes between 2.666 pieces of bacon and 5.234 pieces of bacon. So there's your window. Like this window, that's the window where most of the data points fall. And when we get talking about normal distributions, you'll learn that within one standard deviation, 2/3 of your data points should fall in here if the thing is normally distributed. And if we were just count them up, 2.666 would be here, and 5.234 would be there. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 out of 20, which is a little more than 2/3, but what can you do? Apparently someone didn't make a normally distributed data set. Anyhow, so about 2/3 should sit in here or more. So you've got this little window here to define a typical value. The last question is, which one's better? And that's a hard thing to answer. When you do these analysis, usually you do both, and then you decide which one is a better fit to your data set. So if I look at these numbers, I have a mean value of 3.95 and a median value of 4. Those aren't different, not really. So as far as the measure of central tendency goes, I think either one is fair. As far as the window for catching most data points, between 3 and 4.5, 3 and 4.5 grabs all of this data here, which is most of it. So indeed, a typical value is between 3 and 4.5. The mean value, as we just counted, grabs everything except the 2's and the 8's. So again, those are typical values. It's a nice little range for how many slices of bacon you'd expect people to eat. So that's okay. This is a hard one. I would say with this particular set that either method of analysis makes sense and is a good reflection. The trick is to just come up with some evidence. So I think in the assignment you're going to be asked to think about which one you think is a better fit, and then provide some proof. And the trick to that is you just pick one. It doesn't matter, you don't have to be right. You just have to provide me with some information about why you think that. So if you're looking at your data set and you have a number for your mean and a number for your median, and you feel like this is the better number, then that's all you have to say, is that this median value fits the data better because I feel like that's closer to the center. So I'll leave you to think about that, and I'll leave you a task to try, and then I think we're done for the unit. So onward and upward to two variable analysis.